Hello everyone, welcome to today's webinar, Enabling Flexible Applications. My name is Claudia Kresse and I'm the moderator today. First of all, I would like to let you know that you can send your questions for today's presenters via email. You will see the contact details at the end of the presentation. Are you looking for a way to manufacture flexible objects? And do you know that you can use additive manufacturing technology for these projects? By using 3D printing, you will have several possibilities to create your flexible parts. Today, we want to focus on how application-oriented materials can support you in tackling even challenging projects. Here with me is Rüdiger Theobald from BASF 3D Printing Solutions and Maria Tauler from HP to give you more insights on this topic. Rüdiger and Maria, can you please shortly introduce yourself?
Hello and a warm welcome from my side. My name is Rüdiger Theobald and I will host you today together with my colleague Maria from HP. A few words about myself. My job is Key Account and Business Development Manager for Powder Bed Fusion at BASF. I have a long track record in sales and new business development. I joined BASF 3D Printing Solutions Forward AM 2 years ago, and I'm actively working in the additive manufacturing now since more than 5 years.
My name is Maria Tauler. I work as a Materials and Agents Product Manager in HP. Before that, I did study industrial engineering and I specialized with a master in management and marketing. So I then joined HP in 2017. So I've been working for the last 3 years in materials, in new materials and agent introduction.
So here you see our today's agenda, and we want to start with a brief material introduction. Our UltraSyn TPU01 offers a well-balanced property profile with good flexibility, shock absorption, and part accuracy. It is perfectly designed for strong and flexible performance, for parts with high shock absorption, excellent energy return and resistance to fatigue. UltraSym is a software solution that we offer for design optimization. For the look and feel, we offer complete freedom of design, high level of detail and surface quality, easy finishing including smoothing and our UltraCure 3D flexible coating. And we believe that together with HP, we can offer the best-in-class productivity with high process stability, and from the computer-aided design files to the printed and cleaned parts that can be achieved in less than 24 hours with a very economic 80% reusability ratio of the material. Note that there are certain elements to consider when talking about TPUs. Lattice design matter for rebound and hardness. The rebound is the ability of the material to return the energy it absorbed after it's deformed by a single implant. The hardness, we have here show A of 88, is the higher the number, the higher the hardness of the material is. Then the compression set matters. That's the ability of the material to return to the original thickness dimensions after a compression load during a certain time and temperature. The abrasion loss, the abrasion is given as the loss of volume in square millimeters when pressed with a rotating abrasive paper. And the tear resistance is the resistance of a material to the crack fissure propagation at a constant speed. The next topic that we want to cover is the material performance. Here you can see the main interesting mechanical values of our material. I want to focus your attention to the tensile elongation at break, which is at 300% in X, Y, and 170% in Z direction, as you can see in this little video. And the rebound resilience, which is at 63% in XYZ directions, as you can see here in that video. All details are available in depth in our technical data sheet that you can download from our website. To identify that the Ultrasin TPO1 fits perfectly to your application, we did numerous testing and certifications which are instantly reviewed and updated. So we checked the hydrolysis resistance, the chemical resistance, the UV resistance, the flame resistance, where we achieved the UL Blue card, and as well the FMVSS 302 qualification. We have the low and high temperature resistance from -50 up to +100 centigrades. We did burst pressure tests with different wall thicknesses of the material and different pressures up to 8 bars. We checked the air and water tightness. We worked on multiple processing solutions, which I will touch in a moment. We fulfilled the skin contact qualifications and certain emissions. To enable your application, BASF offers a broad portfolio of services beside the pure material supply and printer compatibility assurance for end-to-end part support. BASF Ultrasim simulation software, well known from injection molding applications, supports to translate from conventional manufacturing into additive manufacturing by topology optimization, print process simulation, material modeling, material testing, print job optimization, structural analysis, and part testing. By design and simulation, the component behavior can be adjusted almost at will and individually. To guarantee a printed part with an appealing look and touch, as well as to improve specific performance aspects, we have developed a unique UltraCure 3D flexible coating. To improve the chemical resistance, the dirt repellency, the surface haptics, the pressability of the material, the abrasion resistance, and the UV protection of the parts. As standard, we have available black, white, silver, metallic, and transparent colors, but we can do any other needed color on demand. Beside our UltraCure 3D coating, we have developed with selected partners chemical etching solutions for perfectly smooth surfaces. This can be used in combination with our coating or also as a standalone solution. So currently, the only effective method to smoothen surfaces of TPU parts, we have partnered with AM Technologies. They optimize the etching and drying process to get a smooth finish for our TPU, but we have also good results through the processes from Luxures and Dimensions. Now Maria from HP will inform you about the printer material workflow.
Thank you, Rüdiger. So first of all, we will introduce the printer that this TPU, the Ultrasim material, will work with. So this TPU material is compatible with the 5200 series 3D printing solutions, which we introduced 1 year ago. So it's the latest printer model that we have today in the market. The aim of this platform is to drive digital manufacturing to scale applications into production. So for that, we focused on optimizing 3 main things, which we will see in the next slide, which is the manufacturing predictability, the economics, and also how to expand into new applications. Manufacturing predictability, what does it mean? So what it means is that our printers will have predictable and consistent print time for any type of part. You will be able to predict the outcome of your parts, have confidence of repeatability on those parts, on mechanical properties, and also we have optimized the dimensional accuracy that we obtain with our technology. To optimize the economics, what we've been working a lot with this new machine is in increasing the productivity of the printers. This new printer has a one balance print mode, which means that the time to part is faster, and this will help a lot reduce the cost of your solution. We have also optimized the agent's consumption, which will also help reduce this cost. And then on the third pillar, we have we want to expand into new applications and markets to be able to have more manufacturing opportunities. To do that, one of the main things that we are addressing is to introduce more materials like this TPU material, which is key to enable new opportunities in the market. All of this is always one of the focus that we have when bringing new materials into our platforms is having high reusability materials, also to help on the cost reduction. Also important also to highlight is that we are not selling only the printer and a processing station. What we have available is an end-to-end solution that combines new software for manufacturing predictability and productivity. It offers high reusability materials for more applications, as we've been commenting, and we offer post-processing and services to help you to scale into production. So please, if you need more information, if you want to know more about HP systems, please feel free to contact me, and we can give you more details on the different assets that we are providing together with the 5200 solution.
So many thanks, Maria, for this detailed explanation. What is maybe, beside the material specifics, of most interest for you? I guess the target TPU applications we have identified. The main segments that we see are automotive, so with soft jigs and fixtures for scratch-sensitive parts like gripers or human protective parts for manufacturing lines, air ducts and tubes, interior components for cushioning with lattice structures for seats, headrests, soft parts in dashboards, and parts to help vibration and noise isolation. Other important applications are the consumer goods, so footwear with customized soles and inserts, sports equipment with lattice structures to improve protection and comfort through customization, lightweight and breathability, gadgets and wearables. Further applications have been identified in the wide field of industrial. For example, components of manufacturing line equipment and robots, any kind of tubes and pipes with customized flexible shapes for easier assemblies, and electronic equipment components like soft and flexible housings. To be a bit more specific, we did support, for example, COVID-19 activities for face masks and components of face shields. The advantage here was that it was very fast local production for emergency supply and replacement parts. The challenge we faced was to pass biocompatibility tests with a short given lead time. Therefore, we had to do special agreements with hospitals, which will take all responsibilities and dismantle all parts after the crisis. In footwear, we already realized midsoles, design shoes, and orthopedic insoles. The advantage here have been the fast development cycles, the personalization, and optimizing design for best performance with the support of our UltraSim simulation software. The challenge we faced here was that we figured out that it's very difficult to realize a high performance and lightweight shoe at the same time. Also, compared with conventional manufacturing, the parts have been at relatively high costs. The next two applications will be presented by Maria from HP.
Thank you. Yes, so the first one, it's related to sports and helmets. So sports in general, but
most particularly helmets, is one of the main applications we are working for this ultra-thin TPU material. Having an elastomeric material with a production system in additive manufacturing opens a complete new range of possibilities. And in particular, what helmet companies are trying to do is they are focusing on improving the safety of their products, and they're interesting and they are really investing a lot on the design with lattices to improve that, because they've realized that with the design freedom that that 3D printing brings, you can design some lattices that, for example, would have rotational movements when they receive an impact, and this protects much better your brain. So it's not only about innovation and in a lot of cases personalization, but here the main driver will be to improve performance and thus to improve the safety of the products, which is a very important thing on this type of cases. Then the second pillar is in industrial. In industrial as well, there are several examples of where this material can be applied, like Rudiger covered, like tubes, protection covers, and so on. But here we wanted to focus on with one example from a wind turbine company. So this application, the one that you see in the image, serves as a safety aid to mount and protect the turbine blade component during handling. And although these are reusable parts, some of these parts may need replacing every year. So therefore you have short runs, and then that's why they needed a solution to be able to produce these short runs. And injection molding was discarded, or other traditional methods, because of the cost. The cost of the molds were too high and the lead times too long. So these parts in particular are under high compression, and only an elastomeric material could resist that. And we tested also with polyamides, but the part failed because they really needed the properties of shock absorption and high compression that this material can resist. Also, what TPU helped us, it was on the better grip to handle the blades, which was also a key benefit for this part. And last, what I wanted to comment here is that they really played with the design, and they saw that with additive manufacturing, they were able to both have high strength and rigidity in some areas, but flexibility in other areas where you require. So you can really play with these elastomeric materials to have both properties in the same part. And now I'll hand over to Rudiger.
Thank you, Maria. So we just finalized some very interesting automotive application projects. So the challenge we have faced was that new seat and cushioning designs for automotive have to be designed, which should also achieve weight reduction and should be location dependent soften. The solution we could offer to our partners here was a simulation project with our UltraSim simulation software in combination with our flexible UltraSynth TPU material. The advantage here is it's a unique design. It did provide lower weight. We could build in a very nice climate control. We could build in personalization, customized and driver-specific seat fitting, and we could bring in our extensive post-processing experience that was needed here. Let me now summarize what you heard in this webinar today. With the support from BASF Forward AM and our partners, you can get easily from the idea of a part or an application to an integrated solution. We start in setting up usually a kickoff workshop to understand exactly the customer needs. Then we screen the parts to print, if needed, simulate it, and consult the overall process. We then usually print benchmark parts, provide testing and extensive post-processing solutions. And at the end, we support the production rollout with the best possible printer material combination. Thank you very much for your attention.
Thanks also from my side for showing us how application-oriented materials can support in tackling even challenging projects. Please also feel free to reach out to us directly via email. You can see the contact details here on this page. So yeah, feel free to use it. And we of course want to thank everyone for the attendance today. And also thank you, Rüdiger, and thank you, Maria, for taking the time.
It was a pleasure. Thank you.